You know that feeling when you turn on the tap and expect water to flow?
Yeah, totally take it for granted.
Right. Well, imagine a world where that's, well, uncertain, especially when it comes to growing food.
Mm-hmm.
That's the sharp edge of water scarcity. It's this critical global issue, and it impacts, well, everything. Our food, economic stability.
And the demand is just skyrocketing, isn't it? Population, cities getting bigger, industry, climate change.
Exactly. All pushing against this finite amount of fresh water we actually have.
It's a classic supply and demand problem, but the stakes are incredibly high. A drought somewhere doesn't just stay there, does it?
No, it ripples out. Affects food prices everywhere.
Yeah, the global supply chain effect.
So for this deep dive, we're really focusing on one specific angle, how technology might help with water scarcity in agriculture.
A crucial area.
We've got this comprehensive study that really digs into how lack of water hits crop productivity.
Right.
And maybe more importantly, what innovative solutions are out there.
Understanding how it affects crops is key. It's not just thirst, it's soil health, pests.
Oh, interesting. I hadn't thought about the pest angle.
Yeah, stressed plants are more vulnerable. The study helps unpack all that.
It really hit home for me thinking about narratives like The Silent Sea, that Korean drama.
Oh, yeah, I know the one. Very bleak.
Super bleak. This like dystopian future where water's just gone and the social breakdown.
Mm.
It's terrifying. It's fiction, thankfully, but it just highlights how urgent this is. We need real solutions, especially for food.
Those stories are powerful warnings, aren't they? They translate the data into something, well, human, show the stakes.
Totally. So that's our mission today, to dive into this study, pull out the key insights on tech solutions. How can we grow more food with less water?
Let's do it.
Okay, so the study breaks water scarcity down to 3 types, which I found really helpful. There's green water scarcity,
AEWS?
blue water scarcity, AEWS, and agricultural economic water scarcity, AEWS.
Right. 3 distinct facets.
So green water scarcity, GWS.
Right.
That's basically when the soil itself is too dry. Yeah, not enough rain.
Exactly. It's the rainwater held in the soil that plants actually use directly if precipitation patterns change or you get droughts.
The soil's like a dry sponge.
Precisely. Even if there's a river nearby, the plants in the field can't get that immediate soil moisture. That's GWS.
Got it. Then there's blue water scarcity, BWS.
Mm-hmm. This is more about the surface water, rivers, lakes, and the groundwater, the stuff we use for irrigation.
Okay, so this is about depletion, overuse, pollution, climate change hitting those sources.
All of the above. Think about major rivers or aquifers getting drawn down faster than they recharge. That's BWS impacting agriculture's main water source.
Makes sense. And the third one, agricultural economic water scarcity, AEWS. This one's a bit different.
It is. It shifts the focus to the economics for the farmer.
So like the cost of water, or whether investing in water-saving tech is even feasible.
Exactly that. It's about the financial barriers. Even if some water is physically there or the tech exists, can farmers actually afford to access it or use it effectively?
So the cost or the risk could actually be a bigger problem than a short-term physical drought.
That's what the study suggests, especially over longer periods. The economic reality can really cripple production. It's about the viability of farming under scarce conditions.
Wow. Okay. So 3 angles: soil moisture, surface groundwater levels, and the economics.
Yep. GWS, BWS, and AEWS.
So we're going to explore how these hit crop production and then really zero in on vertical farming as a potential tech solution.
Right. Understanding these categories helps us see how something like vertical farming might tackle specific parts of the problem.
Okay. Challenge understood. So what did this study find was the biggest single factor? When water gets scarce for a while, what hits hardest?
Well, the findings were pretty stark, actually. It pointed squarely at agricultural economic water scarcity, AEWS.
The economic one.
Yeah. As the most influential factor affecting crop production during, prolonged shortages, like over a month.
Wow. And how widespread was that finding?
It impacted, get this, 86% of the regions they analyzed.
86%?
Yeah.
That's huge. So it's not just, is there water? It's can we afford to use the water effectively?
Right. Exactly. The economic constraints, the costs, the risks associated with scarcity, that's what seems to have the biggest, most consistent impact on actually growing food.
It really frames it differently, doesn't it? Less purely environmental, more socio-economic.
It has massive economic ripples for farmers, the whole ag system, and, well, us as consumers.
Okay, so if economics is such a huge driver, This is where the study brings in vertical farming, right, as a potential technological answer.
Precisely. It suggests vertical farming has characteristics that could potentially address all three types of scarcity we talked about.
All three, GWS, BWS, and AEWS.
That's the potential, yes. Its fundamental design offers solutions on multiple fronts. It's sort of an integrated approach.
Okay, let's break that down. How does it deal with green water scarcity, the lack of soil moisture? I mean, often they don't even use soil, right?
Right. In hydroponics or aeroponics, you've got incredible control. You're delivering water and nutrients directly to the roots.
So no reliance on rain or soil capacity.
None. Hydroponics uses nutrient solutions, often recirculating the water. Aeroponics is even more direct, just misting the roots. Very little waste.
So you bypass the whole soil moisture problem. You control the rain. Precisely.
You essentially create the perfect moisture environment, directly combating that GWS uncertainty.
Okay, makes sense. Now, blue water scarcity, the strain on rivers and groundwater, how does vertical farming help there?
This is probably its most famous benefit, the water savings.
Right, I've heard numbers.
They can be dramatic. Compared to traditional field farming, you're often looking at reductions of like 90% or even more.
90% less water. How?
Because of those closed-loop systems, the water isn't lost to runoff or significant evaporation. It's captured, treated, and reused constantly.
Wow, 90%. That's a game changer for regions stressed for irrigation water.
It could potentially free up enormous amounts of water currently used in conventional agriculture.
Okay, so it tackles GWS with precision delivery, BWS with massive efficiency. What about AEWS, the economic scarcity? How does it help farmers when water is scarce or just plain expensive?
By boosting productivity per unit of water. Massively.
So getting more crop for each drop.
Exactly. You can get much higher yields in a much smaller space using far less water. This changes the economic equation.
How so?
Well, it can potentially make farming viable even where water costs are high or where traditional yields would be too low due to drought. You get a much bigger economic return for the water you do use.
So it directly tackles those economic constraints by making water use much more productive and therefore more valuable.
Precisely. Better yields, less water, smaller footprint. It addresses the economic viability question head-on.
So the study really paints vertical farming as this multifaceted solution.
It definitely highlights its potential to address these interconnected challenges of water scarcity in agriculture.
But like most things, it's not perfect, right? The study mentioned limitations too.
Oh, absolutely. It's not presented as a silver bullet. There are real questions still.
Like what?
Scalability is a big one. Can these systems be deployed widely enough, cheaply enough, to really impact global food production significantly?
Right. Can we build enough of them, and are they affordable?
That's the accessibility question. Can they work for different scales of farming in different economic contexts, not just rich countries or big corporations?
Good point. And any other concerns?
Yeah, the broader socioeconomic impacts. If vertical farming becomes widespread, what does that mean for traditional farming communities, for jobs, for existing food systems? These are complex issues.
So huge potential, but still hurdles to overcome in terms of scale, cost, access, and social integration.
Definitely. The study shows the promise, but also clearly flags these areas needing more research, innovation, and careful thought about implementation. It's an evolving picture.
Okay, so wrapping this up, here's a final thought for you, the listener, to mull over. The study really hammered home that economic factors are often the biggest amplifiers of water scarcity's impact on farming.
That 86% figure really sticks with you.
It does. So the question is, how do we move forward? How can we create policies and, importantly, investments that don't just promote cool water-saving tech like vertical farming?
But also make sure it gets integrated fairly.
Exactly. How do we ensure it's adopted equitably so it's accessible and sustainable for everyone who needs it all around the world and doesn't just create new divides?
That's the big challenge, isn't it? Moving beyond just the technology to the systems that support it.
Something to think about.